Okay, we're going to continue with our lesson on 5.8, which is solving three-dimensional word problems. The second one, we have two boats leaving the same dock at the same time. The second boat travels at 87 kilometers at a bearing of 260 degrees. There's also one more piece of information that is missing over here in the word problem. I'm going to just add it over here. That is the first boat travels 58 kilometers at a bearing of 125 degrees. So that was missing. I'm just adding that in. So they both leave the dock at the same time. The first boat travels at 58 kilometers at a bearing of 125 degrees, and the second boat travels 87 kilometers at a bearing of 260 degrees. How far apart are the boats, and what direction is boat 2 from boat 1? So we have to understand what this looks like, draw a diagram, and understand what it means when it says bearing. So let's say this is our dock. Okay, so it's a horizontal dock. Then let's say the boats are leaving at the same time. So let's call this point D from where they're leaving. And the way it works out for bearing is that we have to look at it as this. Let's say this is north. Okay, so then this is south, this is east, this is west. So when it says that the first boat travels this distance at a bearing of 125, it means from north you're going to go 125 degrees. So this is from here to here is 90 degrees, and from here to here is 180. So 125 is going to be between 90 and 180. So I'm going to draw a line like this and say that this angle is 125 degrees. And this boat is traveling 58 kilometers in that direction, okay, at a bearing of 125 degrees. So what does that make this angle from here to here? So that would be, this from here to here is 90, and then, it's if you did 125 minus 90, you would get the angle as 35 degrees. So this distance from here to here is 35 degrees. Well, similarly, if the angle from here to here will be, because the whole thing is 180, this angle will be 55 degrees. Okay, 55 plus 35 will make this also 90. Now, the second boat travels from that same point, 87 kilometers at a bearing of 260. So from here, it's traveling. So 260 is going to be, this is 90, this is 180, this is 270. So 260 is going to be somewhere between this 180 and 270. So let's say somewhere like that. This is the second boat, and this angle from here all the way to here is our 260 degrees. Okay, so given that, we need to find the other angles, right? We need to find what is this angle from here to here. So this angle, which is what we're interested in, I'm just going to continue this dotted line. So this angle, how much will that be? Okay, so the entire thing from here to this is 270. So if you do 270 minus 180, you'll get this angle from here to here. So 260 minus 180 gives us 80 degrees. So this angle from here to here is 80 degrees. And the distance that the second boat is traveling is 87 kilometers. Okay? And so there are questions asking is how far apart are the boats? So this is the first boat is here, the second boat is here, and you're going to draw a line that connects the two boats, right? That's your line. And you're asked to find what is this distance. Let's call it x. What is the distance between the boats, and also the direction? Is it from boat 2 to boat 1? So let's call this our boat 2, which is the second boat that left. Okay, so that's boat 2, and this is boat 1, and we have to find what is the angle or direction between the two boats. Okay, so in essence, you have a triangle that you can solve for. So you have this triangle, and let's call this B, this A, and this is D. This angle, internal angle, is 80 plus 55, which is 135 degrees here. This distance is 87 kilometers. This distance is 58 kilometers. So you have a side angle side scenario. So you can use the cosine law, because the cosine law is used when you have side angle side. So in triangle DAB, you can say D squared equals A squared plus B squared minus 2AB cosine of B, cosine of D. So this is our D, this is our A, this is our B. We label the triangle so we know what to put for everything. And we're asked to find the distance between the two boats, which is D. That's equal to 87 squared plus 58 squared minus 2 times 87 times 58 times cosine of 135 degrees, and that's D squared, not D. And we find that when you square it and square root the answer, you get 134.4. So therefore, the boats are 134.4 meters apart. Okay, and the second part of the question is asking the direction between the two boats. So how far apart, or what direction is it from boat 2 to boat 1? So we kind of want to find what is the angle here, like for this for B, what is the angle? So if you draw a line that shows the vertical north from here, so if you have the north is like this, you want to find this angle, which is from here to here. And if you find that angle, you can kind of understand the direction of boat 2 to boat 1. So to find that, first we need to find this angle here, what is this angle here? Okay. So we can use that sine ratio, or the sine law, and do sine B divided by B equals sine D divided by D. So angle B we do not know, so sine of B divided by B, which is 58, equals sine of 135 divided by D, which we just found out to be 134.4. And when we solve it, we will get angle B is equal to 18 degrees. Okay, so that means so if you look at our diagram, so go back to our diagram here, these two are parallel lines, and this is like a transversal that cuts them. So if this angle is 80, so you have the, you can see that this angle here also will be 80, from here to here is 80, because of the Z pattern. Okay. You can see the Z pattern from here, like that. These two lines are parallel, there's a transversal, so alternate angles are equal. And we just found out that this angle is 18, which is the angle B. So if you add 80 plus 18, we will find that 80 degrees plus 18 degrees equals 98 degrees. So that is the direction of boat 2. So therefore, boat 2 has a bearing of 98 degrees to boat 1. We'll take another word problem here, which is Manny uses a clinometer to determine the angle of elevation to the top of a cliff as 38 degrees from a point D 68.5 meters away from Manny. Joe estimates the angle between the base of the cliff himself and Manny to be 42 degrees, while Manny estimates the angle between the base of the cliff himself and his friend Joe to be 63 degrees. Find the height of the cliff. So this is, the diagram is already drawn for you. So you can see that here from A to C you have the height of the cliff. The question is asking us actually to find the height of the cliff. Find the height of the cliff. Now this diagram is not given to you in the question. It's actually something you draw afterwards. So you have to draw a sketch, and these lines are what you use to help you to create the triangles that help you solve. So from A to C is the height of the cliff. It's given a distance of h. And as per the information in the question, from a point B at the bottom, the angle of elevation at the top is 38, which is why you see the 38 here. And then from a point 68.5 meters away from B, which is right here, this point D, this distance between D and B is 68.5. The angle between the base of the cliff himself and Manny. So that's the that's where Manny is, and that's where Joe is. So he says that the 42 degrees between the base of the cliff himself and Manny. So this is the base of the cliff, this is himself, and his Manny. So that angle here is 42 degrees. And Manny estimates the angle between the base of the cliff, so here, himself and Joe. So base of the cliff, himself and Joe to be 63 degrees. So you have to read the question carefully and then draw that triangle and try to find the height of the cliff from the information that's given to you. So let's see this. You have two right angle triangles here. One is ACB, right? And the other one is not necessarily a right angle triangle. This one we know is 90 degrees. But this one here at the bottom, that is DCB, is not necessarily a right angle triangle, because if you look at it, this angle is 42, this angle is 63, and this angle is 180 minus 42 minus 63, which works out to 75 degrees. Okay. So in triangle DCB, which is this triangle on the ground here, in triangle DCB, we can do B over sine B equals C over sine C equals D over sine D. So that's B over sine of 63. So that's B right here, which is the side opposite angle B. This is D, that's opposite angle D, and C is opposite angle C. Okay, so that's equal to C, which is 68.5 divided by sine of angle C, which we know is 75 degrees, equals D, which is not known, divided by sine of angle D, which is 42 degrees. So from this, we can find D. If we equate these two, we can find D, which is the distance from here to here, right? Because we're interested in solving this right angle triangle ACB and get more information from it. So if we equate these two, we can solve for D. D works out to 68.5 times sine of 42 divided by sine of 75. And D works out to 47.5 meters. Once we have D, we can now solve for height in the second triangle. The second triangle like this, ACB. And we found out this to be 47.5, right? And this angle is 38 degrees. And we have to find the height of the cliff. So we can, in triangle ABC, we can just use the trig ratio tan. So tan of 38 degrees is opposite side over adjacent side. And then we find H equals 47.5 times tan 38, which is 37 meters. Therefore, height of the cliff is 37 meters. Okay, and then we have another word problem. Emma is on a 50-meter high bridge, and she sees two boats anchored below. From her position, boat A has a bearing of 230 degrees, and boat B has a bearing of 120 degrees. Emma estimates the angles of depression to be 38 degrees for boat A and 35 degrees for boat B. How far apart are the boats to the nearest meter? So you can maybe take a little time to just read the question to understand properly. And then the solution is actually given to you in your textbook. And I want you to read the textbook solution for this. It's on page 330. And the whole solution is solved there for you. Similarly, even the previous example that I did over here is already solved in the textbook. So this is on page 328, the textbook, and this one is on page 330, the textbook, and you can follow through the solution there and see how it's done. Okay, and then when you're done, you can try this as a practice and go on to your homework questions.